Hello, welcome to the presentation of Lab2. In this lab presentation, network applications in Net++ will be examined. Throughout this presentation video, I will show the main features and functionalities of 4 essential network applications based on my research I have done previously, and DHP, PingApp, Telnet app, and UDP app will be covered, and also we will deeply examine their fundamental characteristics, distinctions, and attributes, and examine their contrast between each other. So I want to start the changes I made in the naming, because it assigned us from the Lab2 as a duty. So let's start what I changed in naming. I want to show them side to side for easy to understand. For example, I set name of group 1 as a computer network class LAN1, and group 2 as a computer network class LAN2. These are the names I assigned for group 1 and group 2. For bottom side, I changed the host names as a student affairs software engineering LAN1 and the associated host number, and also I made the name of router and switch associated with it as a student affairs. So let's continue. I assigned name of fiddle 2 in here as a library LAN, and fiddle 1 as a library LAN 2. These are the names I assigned. So let's continue. Okay. I want to start showing net files, because these are the application device settings. I want to start by configurator C, because it's important. The configurator C extends configurator B. What this means is configurator C extends some features, devices, in other words, the inheritance from configurator B to get previously defined devices. What configurator C adds is access point, wireless host, and this is actually as a name of computer network class, library, and so on. As we can see also in here, computer network class and library. Let's move to the configurator B. Configurator B has devices like standard host, like many of them here, and switches, autonomous switches, like these ones, with associated names, and some router settings, as you can see. So let's move on. We have INI file with all these special settings, like DHP2, number of resolute, and so on. All of them has their own explanation. We will dive deeper on that later. So let's continue. For example, just a minute. In XML file, in other words, where we done our customized settings, if you are concerned, yes. In the XML file, we have addresses we have specified. What is done is it assigns our class LAN and interface surface LAN, library LAN, backbone router, and class router, and so on. It assigns their address netmax as a manually, as a custom in XML file, addressing configuration. This is XML file, but pretty basic. So let's continue with INI file. I want to start with the general, because this is where the all the configuration is done. So I will do brief examination with the configurator. Net++ configurator is a graphical user interface, in other words GUI, tool that makes network configurations, development, and administration easier. It enables us to set up different network protocols, define IP addresses, construct network topologies, and configure application settings easily. And other things like the configurator in Net++ gives a wide range of feasibility to easily define and specify network, because it lets us, as a developer, create a visual representation of network as we want for specific network scenarios by choosing components like routers, hosts, and switches, as in here, like in here, and dragging and dropping these components to specific locations. Afterwards, these components are linked to from the network structure. This is the overview of configurator, and also I want to add something as a detail. It allows us to configure various application settings, such as packet sizes and start times, and network protocols such as DHP, ping, UDP, and Telnet. This is the overview. So I want to show the simulation to actually see what we are achieving, what we are doing in here. So let's begin the simulation. I will do it bigger. Just a minute. you're gonna see it better. So I want to start it slowly because there's a one part I want to show. Just a bit. It will start right now, yes. As you can see, it starts by first sending packets to switch. Why they are doing that? Because they don't have any IP addresses as the simulation begins. So they are using switch to send DHB discover packet to network by using DHB protocol. In MI5 we set this as has DHB inverters and also tool and other things. So we can use switches and routers for sending DHB discover, then they will reply us with DHB offer, DHB request and so on to get us dynamic IP addresses by using DHB. So this is what we are doing here to get IP addresses. Then let's make it a little bit faster. Then as usual switch will send packet A1. Then after getting IP addresses, we can move faster. It starts sending packets via access points to the hosts and also this access point we find in here, access points. So let's move on. It starts sending packet. I will make the simulation faster because I want to show the results. There should be enough simulation time to show it. I will wait a little bit to make enough numbers to show. I think that is enough, so let's stop it, then finish it. Yes. Okay, let's go to the online file. Now I want to continue with the DHCP, which is our first network protocol that we present this network simulation presentation. DHCP, which is a dynamic host configuration protocol, or shortly we can say DHCP, a network management protocol that allows devices on the network to be dynamically assigned IP addresses by using a client-server relationship. In a network simulation, a network express the DHCP model servers how clients or devices request the DHCP server for IP addresses and how DHCP servers dynamically assign IP addresses. It's a brief review. Now I want to examine how this happens step by step. Covering it better. It starts by when a client enters the network, for example, when we start the network. The DHCP server is responsible for giving it a dynamic IP address for a predetermined amount of time. We can say it is lease time. In other words, server leases an IP addresses to client. This is the first step after installation. Then the process starts when the client's first service network clients request an IP address by sending the DHCP discover packet to the network. Following the client's transmission of DHCP discover packet in response, the DHB server sends a DHB author packet with an IP address and further network configuration details such as DNS server, subnet max, and default gateway. These are can be configurations. Once the client receives and examines the DHB author packet, the client then notifies the server that it is accepting the provided IP address by sending a DHB request packet. Afterwards, the DHB server then confirms the IP address assigned by sending a DHB acknowledgement packet. This is how DHB procedure generated done in our simulation, step by step. We cover it. I want to give some differences. The key differences between DHB and other protocols. From the purpose of usage, DHB is used to configure networks, whereas the others are used for testing, remote communication, and data transmission. And another detail to add, that I want to add, about the DHB is, in contrast to other apps, DHB is a network administration protocol that is intended to assign IP addresses dynamically to devices for a specific list time that we mentioned before. So on, whereas the other apps, like Pinch app, Tarnap app, and Unity app, are mostly utilized for inter-device communication. This is the main difference. While others mostly it is concerned about communication, DHB is about administration, management. So we can show the simulation just for earning the results, because it is not that much different from the general, just the protocol. So I will skip this part just for waiting. While it was waiting, I want to show that some things I add for making my configuration special. For example, I add list time, sets the DHB list time to 7 seconds, and also max number of clients to 3 seconds. Stop operation extra time, it makes us add an extra 5 seconds before stopping DHB operation, and other lines like DHB set to true, resolved address to true. I included these ones, these special configurations from dhbserver.net, as in right there. If I show it, yes, I add these ones from there, and these are the things I made. So after simulation continue for enough time, we can stop it, then finish it. Yes. So let's see the results. Just we're waiting for the application. Yes, we can open DHB vector. The results file. Just a minute. To open, yes. We can do data and results obtained. We can get lots of different, again, as usual, results. For example, solution spacing, and so on, but I want to see some in our research. Beats right, because in our case it's a client server application basically. We use query for that. So let's analyze bit length. Now I want to examine the query bit length graph. As you can see, there is a graph that shows some peaks and drops. I want to make it bigger to see better. And what this means is the peaks representing the data packets are come and queried. The drops are mean the packet queried and sent or transmitted, in other words, to other devices like host and etc. This is query and transmitting of query bit length. In other words, short peaks like here, when DHB packets are come and queried by the device, and drops are represent packet transmit in other devices, etc. And this graph calculating how many bits waiting in the query in a current time. It's showing us visual representation of it. And I want to make it bigger to show. You can see from this chart which ones are query grouped in simulation by color differences. You can see that. So this is the examination of this. So I want to continue with the pinch app. And pinch app in .NET++ is a simple application dedicated to simulating the pinch operation. We'll cover it. It basically works by transmitting IMCP API request packets to a determinate host to test and analyze network connectivity and measure the performance of the link. This is the reason why we are using it. And another feature is the application computes round trip time. In other words, it is the time between sending pinch packet and receiving pinch up packet. This is a delay between them. We call it RTT in network, and logs the results as the waits for the echo reply packets. And I want to mention how things actually done behind the scenes. The pinch operation involves the program sending RCP echo request packets to designation destination address, then waiting for the application to receive an echo response. This is the first part. Then response handling involves recording and measuring each individual pinch request's runtime time, RTT. The pinch is considered unsuccessful if the response is not received within a predetermined timeout. And this is what is the pinch up actually. So I want to mention what I have done in ini5. This is important because I put this code descriptions, I set up this from the pinchup.net. First I will mention about that. And I add send interval, which is time to wait between pinch. I add sleep duration, which is the time spent in sleep between switching destinations. And I set them uniform. And another one I can mention, I set destination addresses for library 1, 2, 3, and they are the ones I set. And I set packet size is this number. In other words, I can say that just general packet size can be customized, so the pinch contents, customers pinch packets can be altered, and it is specified, as you can see, to 1024 bytes in the simulation setup. And yes, I want to mention the start time. The pinch ups begin sending pinch requests from the host to designation address at the start time, which is in this case 5 seconds in the simulation configuration. And one lastly I want to mention is continuous pinch. I set the true. This is also from the pinchup.net. What this does is application will send pinch queries forever during the simulation because the continuous clock is set to true. And I get these ones from pinchup.net. If we load it, just a minute. From the pinchup.net. As you can see, the parameters I get continuous, packet size, destination address, and all that in here I get from there. Some statistics come from default, like this number loss, RTT. I will show what is the pinch TX sequence, especially I choose this one to show. So let's start the simulation to see actually what it does in the results line. The simulation is similar. Let's wait for rebuild. Let's wait for a certain amount of time to see the result. I think 5 seconds will be alright. Done. Let's finish. Yes. Okay. I would open it. Let's see. Yes. I open it before. Let's retest it. Yes. There is a number of packet sounds. I want to say TX. I don't remember. Let me check from the notepad. Pink TX sequence. I will copy it. There is a key different count. I want to switch to start by count. And this histogram diagram, which you can see there is a continuous pinch up sent, but it is a better way to show, which is vector, which is a vector representation. I think this one can be better. Just a minute. Oh yes. This statistics in pinch up goes linearly. Pinch up in this statistics will follow the sequence numbers, 1, 2, 3, and so on. Transmit pinch packets, each transmission between them as a number. And statistics will record it each time there is a sent in our simulation. Here, as you can see, linearly it increased because I set it to true and statistics corrected. This is the pinch up. So let's continue with the time method. Time method is a little bit different than the previous ones we mentioned because it has some special case which comes from text-based communication. And time method is basically clients and server interaction system. And Telnet is used, as we mentioned, text-based communication protocol to connect remote systems or servers. This is brief examination. So I want to give some brief examination of the other parts like Telnet server and Telnet card, because it's basically construct on this idea. Telnet client initiates the connection to the Telnet server at the start and communicates by sending data, typically comments and receiving output in a textual format, which is what we mentioned earlier. Telnet server monitors for incoming connections on a protocol port and manages communication by replying to client queries. Basically, client send to server, server reply query in a textual format, so on. And let's start explaining what this does. Telnet client provides commands for the Telnet server to process when it receives connection request. And I want to mention the INI set in this example. So let's begin. This is the destination address, LAN 1 host 3, back of the network, connection address. And network LAN 1 host 3. Destination address, library, LAN 2 host 1. We will see when the simulation starts. And the start time set to exponential 5 seconds in that. And I set connection port to 23, which is the standard Telnet port. I use the standard one to make it parallel with the real world. It will watch incoming connections from clients from this port. And one other thing to mention is I set local port number to -1 to indicate a temporary local port for the Telnet client. Or we can say that client's local connection is set up with a dynamic port, which is -1, also indicated in the net file. This will dynamically assign local port for the connection by the application. This is INI file. And I want to mention some things in the net file. Let's begin. These are some configurations I use most of them, as you can see in INI included mostly. And let's continue exploring net file. Let's open. Conversion is a little slow. Just a minute. It's open. And open it. Okay. I will talk about packet sent, packet received, and some of the other statistics like incoming data rate and incoming packet length after the simulation is done. We will see. So let's continue. Turn it off. I already opened it. Start. It is faster. As you can see, it uses the destination addresses, connection addresses that we specify. If you look closely, so I will make it faster because I want to see actual results file, and I want to mention the things I want to check. I think that's enough. Let's finish it and go to the results file. And where is it? So I want to show some results in the Telnet app, which I selected earlier. And I want to start by writing result filter. First, I want to start with the packet sent, which I found in here, and packet receipt. And also I found one more thing I will show later. I will first start packet sent. And we hear data. Yes, let's begin. This is the histogram of the packet sent. As you can see, every time packet sent from one host, the desired host in here, for example, when this packet sent to this is incremented by a sequential number by 1, like a host one. You can see which one sent. The ones sent also ones received. We will see at the data receipt also, the packet receipt results also. And what this does is every time packet sent from one specific host, the Telnet logs it by using signal. And this gives us a sequence of time where one packet are sent from one host to other. And the dots in here is a time moment after communication happened. and it's a can't solid respond to each other. So let's continue with the packet. It's a similar thing. And yes, packet, the send and receive is same, and it is same actually. Packet receive will work as a time parallel every time, and it uses sequence time here, as before we mentioned earlier. It's another result that I found. And I want to say one more thing, which is incoming packet. Incoming packet here. Yes. I want to say vector. This one. Yes, this one. The histogram. As you can see, there is a large one block of packet length, and there is a small ones actually, indicates 2400 and 2500, but mostly with around 400. What this means to us? This record gives us some information about incoming packets, as the names mentioned, packet length, and received by the target server. In the simulation we defined it. Because target app is a text-based and most time transmits small messages, and I know how we can define it. So let's go to the again. Define it. Define it. Yes. And most time transmits small messages like replying client with comment messages, as we mentioned earlier. And this result is programmed with varying because of varying lengths we mentioned, like this small ones, and most of them come in here. So let's continue with the UDP app. UDP app is kind of different protocol, transport protocol it is also, but some differences came. We will cover it right now. And let's start. UDP app is kind of special .NET++ application that simulates the actions and characteristics of user datagram protocol, UDP application. And for mentioning what it is functionalities and characteristic behaviors, attitudes, we can list as following. As a lightweight and connectionless transport layer protocol, UDP enables hosts to communicate with one another without forming a connection, which makes it appropriate for applications where reliability is not crucial as speed. The main feature of UDP is connectionless, and this comes from idea of sending data too quickly. Because it is sending data too quickly, it is prone to packet loss. This is the one difference from the TCP. TCP considers reliability and making connection by handshaking, but in the UDP, it is not making connection and sending data too quickly without giving us certain reliability. And one other feature of UDP is it can stay continuous sending data if the congestion time even in the congestion time, it doesn't matter, it can still send data. And another detail, simulation, in this simulation I use UDP basic app, which is common for UDP in .NET++, and I want to explain how it works, what it does behind the scenes. Data packets are sent via UDP from source to host to a destination host using UDP app. In conventional client-server arrangement, data is sent from one host to client to another device. It can be host, server, or sync. The way the application is configured determines whether the data is sent continuous streams or in burst. We are going to cover what this burst means. In my INI file, I set destination address as a stream of host engineer host 1, as you can see, and local device address is w1 host 1. And in here, also I set the destination and local addresses. And I set local port 1000 and destination to 2000, and in here I also set destination port in 1000 in here and local port over 3000 in here. For just simulation purposes, it is not related to real world applications, just for simulation purposes. And also set the start time as 5 seconds, it will be sent at 5 seconds. And message wait I set the 1024 bytes, and most important thing in the UDP app configuration is send interval. I set the send interval to 500 milliseconds. It's a fixed number. This means our application is continuous, fixed. But if I make it even more smaller, close the zero, the application will send packets too quickly. It will result in burst. As I mentioned, we can configure it like that. But in this case, I make it fixed. It is not bursting. So let's continue with the net file. Just a minute. Yes, I use some configuration from here. We will cover some signals here. After this, simulation is open. So let's open it. The simulation I already opened it, just starting it. It's initializing. I will make it quicker because all the applications usually look similar because they are all using same general part in the INI, and only difference comes from the application we use. It makes the difference in the background, and statistics also different in each other because we use different applications, for example, Kinjap, UDP app, and others. But usually they are all same. And let's stop the simulation to going to results part. So let's continue with the results. I will type packet sent. I find it in here. I will use it. Packet sent count. Open it. So we can see which host sent packet to which, and it's as give us second standard visualization by using statistics when packet sent, as we saw earlier. And other ones, and I got this one, play, sequence, non-packet, histogram. There is a one big block of mass and a kind of small histogram in here. The reason we choose this statistic is the frame sequence number packets represents as the statistic data of ordered packets, order of packets and packet list. And it is very useful for analyzing and demonstrating our application performance and packet list and some other features that UDP has. And it can be also used for debugging for some applications in special case, because when we use UDP, we have chance to face some loss and some other bad habits of using the UDP app. So we should check it by using this statistic for analyzing what is the loss we earn, what is the benefits we earn in these special cases, and analyzing received packets and show error occurrence to the inside the applications to be as a report to other ones to show the performance. And this is the frame sequence number packets explanation. And also I want to show one more. This is close it. This is our profit vector. It is kind of not changing because we only have limited number of hosts, and destination address and local address. Because of this reason, we only have one statistic line in profit, which is also useful for analyzing our behavior in UDP in this case. As a result of this lab presentation, and this lab presentation covered and analyzed behaviors, characteristics, and contrasts between network applications. These analyses and simulations we done makes us deeply understand and analyze how the Kinjap, Thermocap, AHP, and UDP functions inside the network. Each of them shows their own functionalities in this packet flows, and especially in statistics parts, inside results, and even in the communication. And at the end, this presentation is covered real-world applications in the MS++, showing us how these network applications can be configurable and can do different things. And I also covered lots of different cases by configured identifier using the makefile of each of these applications, and this makes us being even closer to real-world network applications. This is the result of this network lab presentation.